Okay, so now we're looking at question 3, which is going to be like a numerical method sort of question. So firstly, we want to be showing that this thing here, this equation here, has some sort of roots alpha, and the roots between these values here. Okay, so the way this works is if we've got some sort of function and it's a continuous function and it cuts somewhere, some value of x that's going to be the root, then I just put in a value a little bit to the right of my answer, and it should be positive. This curve should be positive at that point, and then it should be negative at this point here. Or if the curve cuts like this, it should be negative at this x and positive at this x over there. Okay, so what we're going to be doing is we're going to be putting minus 0.33 into that as a value of x into that, and we're going to put minus 0.32 into that as value of x, and basically we want one of the outcomes to be positive and one to be negative. And if one of the outcomes is positive and one of the outcomes is negative, then we know it must have cut the x-axis between those points, and then we've shown that there's a single root between those points. Okay. So we're going to put in minus 0.33 plus 1 plus 3 minus 0.33, and that's all to the power of a quarter. If we do that, we get minus 0.01. Okay, and then we're going to this is 3 part A. Then we're going to put in minus 0.32 plus 1 plus 3 times minus 0.32, all to the power of a quarter. And when we do that, we get 0.1. So this is negative, this is positive, therefore there's a root. Therefore there's a root, so alpha is greater than minus 0.33 and less than minus 0.32. Okay, for part 2, show that the equation x plus 1 plus 3x to the power of a quarter equals 0 can be rearranged. So this is just algebra. This is just trying to rearrange this. So we're starting off with, this is 3b, we're starting off with x plus, and this is 1 plus 3x. Am I writing this down right? 1 plus 3x to the power of a quarter equals 0. Yeah. So I'm going to take away the x from both sides. Gets me there. And then to get rid of that quarter power, I'm going to raise everything to the power of 4. So on this side I'm going to get this, and on this side I'm going to get minus x to the power of 4. Now this is a negative here, and so the negative to the power of 4 is going to become a positive because this is an even index there. So this is the same as 1 plus 3x x to the power of 4. Okay. And then it's just a case of carry on. Well, what are we trying to show actually? X is a third of that. Okay, so we're going to take we're going to keep that 3x there, x to the power of 4 minus 1, and then so x is going to be 1/3 of all of that, and that's what we're trying to show. And you can see that they're the same. That's 2 marks. Okay, finally, for free part C, it says use the iteration xn plus 1 is equal to xn to the power 4 minus 1 over 3, with x1 equaling minus 0.3. So it's doing this iteration from what we've just found. So this is going to be xn plus 1 equals basically xn to the power 4 minus 1 all over 3. So those things are the same, but this is like an iteration formula. And it says that x1 is minus 0.3, 1. Is that right? Minus 0. Sorry. No, it's just, let's get rid of that, it's just 0.3. And so if I put x1 into here, take away 1, do it to the power 4, take away 1 over 3, I get x2, and x2 is minus 0.331, and then I take that and I put it in here, 2 to the power 4, take away 1 over 3, I get x3, that's minus 0.329. I take that, I put it into there, power 4 minus 1 over 3, and I get fourth one, which is minus 0.329. Okay, and that's part C.